Well, how are you? This is our last lesson of the term, and I thought we'd do something really interesting. So let's see if we can fit students exactly on buses. It's a bit of a trick. Let's look at the situation. There's 538 students at John Day Mathematical Grammar School. Quick call to Murray's coaches ascertained that they have only 28 seat and 57 seat coaches available. Can the students at John Day Mathematical Grammar School be seated on Murray's coaches such that there's no spare seats? And if so, in how many ways can this be done? Do you think that we could fill exactly a certain number of 57 seat coaches and a certain number of 28 seat coaches? So we totally fill the coaches, there's no spare seats. Maybe it's not possible. Maybe it is possible. Maybe we can do it in a number of ways. First thing I wanted to point out before we launch into this is something about positive whole numbers, positive integers. And it's something that you would have known from back in primary school. So if I can just grab myself a pen. If I have a couple of integers like, say, 3 and 2, couple of positive whole numbers, if I add them together, what must happen? What type of number must I get? I must get another positive integer, right? If I multiply, say I had 17 of some positive whole number, some integer, like 17 times 4, and say I subtract off some other integer, maybe 10. What type of number must I get? You're right, I must get an integer. Now, I guess it could be possible that it's negative if I subtract something big enough off, but I must get an integer. I can't get some sort of decimal-y, fraction-y sort of situation. If I start with integers and I add or subtract or multiply integers, I must always end up with another integer. Yeah, by the way, if you can't handle that not being answered, there we go, that's 58. So what about if I divide? Okay, well, that could cause a problem. Sure, if the integers were like 12 and 3 and I did some division, I could end up with another integer. But quite often I'm not going to be able to be sure of that. Like 5 divided by 3, that's not going to be an integer, is it? So what we've established just now is that if you definitely have yourself some integers, if you add or multiply or any combination, you're going to end up with integers. And that's a very important point that's going to help us in what we want to do today, because we're working with whole numbers. We want a whole number of buses. All right? We don't want to order 2.5 28-seat coaches, 3.2 57-seat coaches. That's not going to work for us. We've got to order a whole number of 28-seat coaches. We've got to order a whole number of 57-seat coaches. And all together, the number of seats on the coaches that we order all together have to add up to 538. I mean, you could guess away, say you thought maybe there's 5 57-seat coaches. Well, then you've got to work out how many 28-seat coaches you'll need, and you have to sort of do an educated guess and check. Like 5 57-seaters is going to be about nearly to the 300 mark, 290 or so. And that means you've got still another couple of hundred to go. So I'm going to need at least 10. I'm going to check 9, 10, 11, 12, 28 seats. You could be out with your calculator, guess and check. You might be successful. You might be. You might be able to guess and check pretty quickly, because these numbers aren't too huge, are they? You might be able to guess and check pretty quickly how many 57-seat coaches and how many 28-seat coaches I would need to get to 538. Well, if you know for sure there was a solution, if there was a solution, you might get there quickly. But the question doesn't just ask that. The question's saying, can it be done? And if so, in how many ways can it be done? So guessing and checking might get you one way, if it can be done. But then you'll just have to keep guessing, checking every possibility in the world to make sure you haven't missed whatever other ways. Is there another mathematical way that we might go about this? Well, let's go all algebra-y, to make up a word, algebra-y on this question. You know, let's let X be the number of 57-seat buses. I'll just write X 57-seaters, and let Y be the number of 28-seaters. How about we start like that? All right. So if I have X, if I have one 57-seater and I have 5 28-seaters, that's how many students will be used up, right? Sorry, there'll be one lot of 57. I need to go 57, sorry. And there'll be, if there's Y lots of 28, there'll be Y lots of 28 students. That's how many will be used up. So I'm going to write that in a clearer way for you. Let me rub that out. And let me make a bit more sense of what I was saying. What I'm trying to say is that for each of those 57-seater buses, right, there's 57 students used, right? So if there's one, we've used 57 students up. If there's two, we've used 2 lots of 57, 114 students. If there's 3, we've used 3 lots of 57, right? If there's X of those buses, we've used up X lots of 57 students out of our 538. And X lots of 57 can be written as 57X. 57X students are on the 57-seater buses because there's X lots of those buses, X lots of 57 seats. On the 28-seaters, we've got Y lots of them, right? Y 28-seaters, 28 seats used up per of those buses. So Y lots of 28 students are seated on those 28-seater buses. So I write 28Y. So if it turned out that there were only 56 students seated on the 28-seater buses, well, Y must be 2. 2 lots of 28 is 56. So that's the total number of students. The number that are on the 57-seaters, X times 57. The number that are on the 28-seaters, Y times 28. So that must add up to 538 because that's how many students there are at John Day Mathematical Grammar School. All right. Now, X is the number of 57-seat coaches. It must be a positive whole number. So it's definitely a whole number, an integer. Y is the number of 28-seaters, so it must be a positive whole number, but therefore it must be an integer. So I'm going to rearrange this and see if Y for sure ends up equaling to an integer that I can just, boom, see the answer. Watch this. I'm going to say 28Y equals 538 minus 57X. I just minus 57X off both sides. Right? Then I'm going to divide by 28 to get the Y by itself. Y equals 538 minus 57X divided by 28. Well, looking a bit fractiony, not real happy, Jan, with the situation. Of course, that if there's an answer, what I've written there on the right-hand side is not a fraction, right? If there's an answer, that stuff works out to be a whole number. But I like things for sure to be either added or multiplied, because I can be sure if they're added or multiplied that the final answer I've got must be, you got it, an integer, must be a whole number. If I start with whole numbers, add them or multiply them or combination thereof, I end up with whole numbers. So I'm going to apply a little process here, just get myself a bit of room. What I'm going to do, I'm going to write down that this is, now I need to work out how many lots of 28 go into 538. I think I'm going to need a calculator. I'll pull up my old calculator and I'll figure that one out. Turns out that 538 divided by 28 is 19.2. So there's 19 full ones and then 0.2. So 19 lots of 28 plus, all right, now 19 lots of 28 is 532. 19 lots of 28 is 532, but I want 538. So 532 plus 6, good, right? Plus 6 equals to 538. All right. Now, what about 57? 28 goes into 57, yeah, well, twice, doesn't it? 2 28s are 56. So I'm going to write minus 56x and then minus another x to get minus 57x. And this is all divided by 28. Okay, so I've got my 19 lots of 28, my 532 on 28. And I've got my minus 56 on 28. And I've also got my 6 minus x left on 28. Now, why would you do that? Just to see what whole numbers I can pull out of there. Just have a look at what happens. This is 19, because the 28's cancel, minus 56 on 28 is 2, 2x, and then plus 6 minus x on 28. Now, let's assume that there is an answer. Let's assume that there is a situation where both x and y, the number of 57-seaters and the number of 28-seaters, can be multiplied by the various numbers and actually end up equaling 538. If there is an answer, then y, right, which I've been saying is equal on the left-hand side here, all the way down, then y must be a whole number. Yeah. Yeah. What are you getting at? Well, 19, whole number. 2 and x must be whole numbers, because if there's an answer, right, x is the number of 57-seaters, and we're saying if there's an answer, it's a whole number. So far, that all combines to give me another whole number for sure, because we said that at the start. If I add or subtract or multiply a bunch of whole numbers, I get a whole number answer. So this is looking good. But then I end up with this 6 minus x on 28. It's looking a lot like a fraction, but I know it's a whole number. If y is a whole number, then that guy, that 6 minus x on 28, must also be a whole number. So what I'm going to do, scroll down here, and I'm going to say, let u equal 6 minus x on 28, where of course u is a whole number. It must be, if the situation's going to work out. Now, if I keep going, you'll see this process, but if I keep going and it just doesn't work, well, then my assumption was wrong in the first place. But we've got to work with this assumption. If it's true, then that is a whole number. So if this all works out, it'll work. So I continue on, but I'm going to need some more room here. So I'm going to need to just tab down a bit and make sure I've got some more room back on those pages down there to do my working. I don't know how long it'll take, but let's have a look here. Okay, so U's definitely a whole number. So let me rearrange this to see what I get for X. Just grab a pen and I'll grab a different color now because, I don't know, it's a different phase of the question. Now I've introduced this U. So I'm going to rearrange this. This says 28U equals 6 minus X. So X equals 6 minus 28U. Well, that's happy days because U is a whole number if this is all going to work. And X appears to be made up of a whole number and another whole number times by a whole number. And we know, even though there's a subtraction there, that when we perform that sort of operations, we get a whole number. That means this is all going to work out, right? So what I'm going to do is this thing called parametrization. I'm going to write an equation that was once made up of X's and Y's. I'm going to write it in terms of some other letter. Okay, I've already kind of done it. I've already started doing it. I've done it by saying that X is 6 minus 28U. Now I want to say, what is Y in terms of this letter U? Okay, so I'll scroll down and give myself a bit of room. Y is 19 minus 2X. And then plus 6 minus X on 28. I just got that from up above here where I'm colouring in an asterisk there on the page. I just rewrote that at the top of the page. Now, instead of 6 minus X on 28, I can write the letter U. Why can I do that? Well, I'm circling it here. I'll put it in a cloud. I'm putting it in a cloud. I've already declared that U is 6 minus X on 28. So if I see 6 minus X on 28, I can clearly write the letter U. And I do see this. I do see this here. So I'm going to write plus U. All right. Now I've got 19 minus 2X. All right. Y is equal to 19 minus 2. But instead of X, I need to write something that has the letter U because I'm trying to write the X and the Y in terms of some other parameter U. Well, it's written above. So where I'm putting a little star, there's a bad star. Let me try drawing some better star. Oh, look, they're getting better now. Oh, unleashing my star drawing technique there. Where I'm drawing those stars, you can see it says X is 6 minus 28U. So instead of X down here at the top of the page, I'm going to put 6 minus 28U. All right, let me work what that is. That's 19 minus 12 plus 56U plus U. So Y is equal to 19. Oh, I don't need to do 19 minus 12. I can work that out. 19 minus 12. 19 minus 12. That's right. 19 minus 12 is 7. And 56 plus 1, 56U plus 1U is 57U. I'll just put a little circle around that. I'm happy with the two things that you can see that are, well, they're not circled, but I've done like a closed loop around those two things there. And I'm going to just scroll down a bit. I'm going to rewrite those. X is 6 minus 28U. So let me get another pen color. Let's go purple. X is 6 minus 28u, and Y is 7 plus 57u. This is fantastic. Right? U is a whole number. That means X is a whole number and Y is a whole number. And I want X and Y to both be positive whole numbers. I don't want a negative number of buses. Remember, X is the number of 57-seat buses, and Y is the number of 28-seat buses, and they've got to be positive whole numbers. I'm going to write that down here. X has got to be bigger than 0, and Y has got to be bigger than 0. Now, X is 6 minus 28u, and Y is 7 plus 57u. And they've both got to be bigger than 0. So I'm going to solve that inequality now. Remember, when you solve inequalities, it's just like solving equations. However, if you ever times or divide by a negative, you have to reverse the direction of the inequality sign. So let's do that now. Let's minus 6 off both sides of this. And let's divide by negative 28. But because I divided by a negative, I reverse the direction of the inequality sign. So that means, if I just scroll down slightly here, that means U is less than 6 on 28. Okay, I could 3 on 14 if you like, right? But I'll just leave it as 6 on 28. Okay, over here, I'm going to minus 7 off both sides. And I'm going to divide by 57. I didn't divide by a negative, so I don't need to reverse the direction of the inequality sign. Okay, you're probably thinking 7 on 57, what sort of number is that? All right, so I'll go the calculator and just decimal it for you so you've got a vague idea where that is, right? 7 on 57 is 0.12-ish, right? So U has got to be bigger than 0.12, actually negative 0.12. Remember, if you're bigger than something, you're on the right-hand side of it on the number line, right? Bigger stuff goes out to the right. Smaller stuff goes way down to the left on the number line. Oh, what does 6/28 look like? 6 on 28. That's 0.214, right? I'll just write U is less than 0.21. All right, so I'm going to draw up a number line. All right, there's 0, there's 1, and there's -1. I'm going to plot where U is allowed to be, but I'll do it with a different color. I'll do it with some lovely green. So 0.21 is sort of there, and negative 0.1, negative 0.12, like negative 1/10-ish, is about here, right? So there's 0.21, there's negative 0.12. And we're allowed to be bigger, so to the right of the negative 0.12, right? To the right of it, but less than 0.21, right? So that means to the left of that. That's why I didn't color in those big circles there. They're just around those points. But anything in here is where I'm allowed to be. But wait, U is a whole number. For this to all work, U is a whole number, right? Can you see a whole number that lies in between negative 0.12 and 0.21? Yes, you can. The number is 0. Now, wait, you're saying that's not a positive whole number? It's got to be positive. 0 is not positive. I understand that hesitancy, but that's just the number U. U can be any integer. It could be negative. I don't care. What I want to be positive is X and Y. That's what I want to be positive. So I'm saying U is equal to 0, and I'm saying There's only one possibility. Now, on another day, another question similar to this, maybe it might go between negative 2.5 and 1.5. So you might get -2, -1, 0, and 1. You might get 3 or 4 solutions. You might get 30 solutions, right? But here, the only possibility is there's one solution. And what is that solution? Well, U is 0, right? So I need to look back up here at what X and Y are equal to and put U equal to 0 in those, okay? So I've got to throw U equals 0 in there, and that'll tell me my values of X and Y. 28 times 0 is 0, 57 times 0 is 0. So that just leaves me with X equals 6 and Y equals 7. Can it be done? Yes. How many ways can it be done? One way. What is that? I want 6 57-seaters and 7 28-seaters. So going back to the original question, can they be seated so there's no spare seats? Yes. In how many ways can it be done? One. And we want 6 of these and 7 of these. And I'm just going to check on my answer. 6 lots of 57 plus 7 lots of 28 is 538. This type of equation is called a Diophantine equation. Diophantine equations are equations where you want to get solutions that are positive whole numbers. And this is a great example as to why. There might be an infinite number actually of solutions for X and Y, but there's only one positive whole number solution. And that's what matters to me in this circumstance. All right. Well, I hope you enjoyed our last period of the term. And I hope you enjoyed working with me on working out for my mathematical grammar school, whether I can actually seat my students or not without any spare seats. And I can do it. So at least I'm going to maximize their school fees on their buses and so on without any wastefulness. Have a good holiday, and I'll see you next term. And now I've got to figure out how to stop this recording.